Wait, take. 9 o'clock pa yan. Sige, take.
Hi, sorry everybody. I got overlapping meeting schedules, so I apologize. There was a confusion with the meeting setup, so. Okay, I'm gonna go ahead and let me assign co-host real quick.
Just Sarah T, not Sarah then.
Okay.
And I'll exit out right now. Because I was going into your email to send her a message because I was getting a little concerned because she's usually on the top of it. So.
Yeah, sorry. I had previously scheduled a meeting and then I forgot and I set up another meeting that's overlapping. So I clicked on the wrong one. I apologize. Okay, so I think I got everybody here. Welcome to CIS824B. We are covering networking in the next 4 weeks, starting this week. So we are gonna go over some of the tasks that we're gonna be doing. So first, if you can check out the syllabus, that's on Canvas. It's similar to what you've seen previously in the other class. But if you didn't take the first part, this is part 2 of the certificate that's non-credit. And so when you complete 3 classes, you will earn the computer maintenance and cybersecurity certificate, okay? All right, so I'm gonna get into Canvas and then I'm gonna screen share. If you have any questions, please let me know, okay? Make sure, before I share screen, make sure we get everybody on mute. So if you have questions, please unmute and ask, okay? So on Canvas, you will find your course information, as most of you did already. So this is CIS824B. This is part 2 of the 3 in the computer maintenance security certificate. We will be doing a live Zoom session weekly from today until October 17th, and that will take care of the course. We are meeting every Saturday from 12 to 4. Mostly we're gonna handle a lot of the assignments during the session, and then there will be some work that you will be doing outside of class. So the Zoom information is there. I apologize, there's a confusion this morning. And so this is where you would obtain the information to access Zoom. For the syllabus for the course, you can view that within Canvas or you can download it. So the course format is in the span of 4 weeks, and we're meeting online every week on Saturday. In this course, we're going to cover different types of network. Starting today, we're going to talk about different topologies. How is this interpreted in a network terminology? And then we're going to talk about components of network, including different types of system, appliances, cabling, the media, like wireless. Then we're going to go into network layout and design, and you will do some of that today in the lab. So we're going to really look at different types of network and how to design it. And then we'll get into communication of the devices, looking at configurations of the systems, including the switches, the routers, and the addresses. It's important to understand the addresses concept because in many cases, you will work with addresses when you set up a network. Starting next week, we're going to start going over the OSI and the protocols, which is what the industry relied on to really establish communication protocols in various layers. Then we'll get into different types of ports, meaning the physical and logical connection for the systems, and how to really look at network applications that would tie to those ports. For example, if we're looking at web application, how is that communicated from one server to the next? Then we'll talk about troubleshooting and resolving network issues. And we're mainly going to focus on smaller scale network for this course. And then we'll go over how to upgrade and plan for upgrading in the case if you own a small business and you want to scale up to expand your business. So your learning outcomes include the functions for small home and network appliances, including your Wi-Fi routers, and then you can add, you attach network storages and other type of appliances. Then you're going to perform basic network troubleshooting and tasks in the home or business networks. And ultimately, we will design a plan on how to upgrade and maintain performance over time. There's no prerequisite for this course, and the textbook I'm using is optional. So if you plan to study for Network Plus, you can use a study guide like the suggested textbook. I use notes that I would release every week for you to go over the concept. And I base my notes on some of the chapters in this textbook. We'll talk about Network Plus certification as an option for you and how you can go about achieving that. So the procedures for the courses, for this course is I organize everything in a module in Canvas. So every week we would have a different module, and in each module you will have assignments, lab, and project and quiz. There will be time that we won't do project parts, but I want you to incorporate some hands-on activity as part of the project. It will enhance the learning process. I do take late work, and every week that it is late, it will be penalized 10%. Since this course is 4 weeks long, I don't take any late work after the closure of the course because I have to complete grade submission. So I like to keep late work within the 2-week scale. And we will do some in-class assignments, and those are mainly question and answer, where I will go over the concept and help you understand what the terminology would be and how to really configure or troubleshoot the network. We will have some hands-on projects. This will be outside of class, where you will do various tasks to look at your existing network at home or in a small business to be improving or maintaining such network. Then we will have weekly quizzes, and mainly we will have at least 3 quizzes throughout our sessions. I often set up the quiz with the due date. Since we meet on Saturday, I usually give you a week and you have 3 attempts in your quiz. The best of the 3 attempts will be recorded as score. As far as grading, this class is based on pass or no pass. So if you have ABC as a grade in Canvas, you will receive a P, which is pass. If a person receives below a C, which is D or F, that will be a no pass. And the grading scale you can see on the bottom of page 3. I use regular standard grading scale for community college. There's no A pluses or A minuses, so, or B plus, B minuses. So as you can see, I don't give pluses and minuses. Now, for the student that receives a no pass, this student can file an EW, which is the end of the session withdrawal. And if you need the information, you can visit the college website or you can reach out to me. I will provide you with the document. You need to file that with student services. So for our grading categories, our quizzes will be, I'm sorry, I think there's an error here. Actually, no, that's correct. Quizzes will be 20% of your grade. In-class assignment participation will be 30% of your grade. Lab activities will be 30% of your grade. And your hands-on project will be 20% of your grade. Now, in general, if the students receive 100 on everything and opted not to do the hands-on project, the overall grade will be 20% less. So just keep in mind that you want to complete the task so that way you can get a passing grade in the course, even though it's not weighted to the GPA as a credit course, but you want to complete the certificate, and that's the whole objective in this particular set of classes. So overall, I use student code of conduct that's following the college policy. We just want to make sure that we respect each other. We just want to make sure that, you know, we value each other's opinion. And we want to give everybody the opportunity to be equitable, and we want to have a diverse learning environment. So if you have any issues, you can also file a grievance complaint form, and that will go to the academic department, the Dean of Instructions, and the VP for academics. Now, for the students that miss class more than at least 2 sessions, I normally drop the student from the course. Since this course only have 4 weeks, we like to make sure we have attendance. And if you have to miss class, just make sure you send me an email so I can let you know what to at least follow up with you. And then if you want to drop the course, you can do so before the deadline. I think they give you approximately 3 weeks to drop this class, or 2 weeks, I believe. So you can check WebAdvisor for that. Any behavior issues will be reported to Student Services Department and Academic. And usually I don't have problem in this area, but in any case, that could result in dismissal from the course, and you will receive additional advising from the administrators. There is a zero tolerance cheating policy, meaning that you want to do your own work. This class is about integrity and to have our own skills built throughout the sessions. Do not copy and paste other sources online. You can look at and research information online. However, we want to make sure that we have integrity in our work. Okay. So in the case of plagiarism, I normally file a form, and the student will have to be counseled through the Vice President of Academic, and it goes into the file. With accessibility, I set up the course in such that the content is accessible. However, if you need additional time for quiz, which is given approximately, I give 60 minutes for 10 questions, so you get 6 minutes per question. So if that's not enough time, you can contact the SPS department. They're located in the library building on campus, room 221, or you can visit their website. You can find the contact information, which is the phone number you can call, or you can send an email. With that, you have to file the request, and then they will forward the request to me, and I will make appropriate accommodation. I do hold office hours during the semester for all my classes. Monday and Wednesday, I'm available from 11:30 to 1:30. On Tuesday and Thursday, I'm available from 4 p.m. to 5 p.m. I mainly schedule this so that way the other courses and you as students can attend the office hours. But if you cannot meet during this time and if you need some help, you can set up an appointment and I will schedule your appointment based on availability. So I will communicate with you on your schedule and then according to my schedule. I am very responsive in email. So if you contact me via email, I usually respond pretty quickly. But at the most, it will be 24 hours. Now, if you can't get something resolved via email, it's best to see me during office hours so I can help you via Zoom. Okay, do you have any questions? So all of this information is also incorporated in the Canvas module. So you can also find the information by clicking the module and looking at the first module. Your grade is usually updated weekly. So after this week going into next week, after you submit all your work next week, I will start updating your grade. So here again, you will find my office hours information. And I included some of the Moreno Valley College resources. I want to point out that in the case where if something happens to your computer during the course, you can access the laptop loan program and request a loaner laptop so that way you can continue with the course. There are additional information here like academic counseling, tutorial services, so you can find that here along with the same information on the college website. Okay, so in that module, I have a course plan. This is mainly going to be the layout of our activities throughout the 4 weeks. So if you have questions about what to work on, you can look at this course plan, and I do modify this as it's needed. If I feel like we need to spend more time on certain area or reduce the workload because you have a lot of things that are due, then I can make the adjustment here. So you can check this out to kind of give you an overview of what you need to do in the next 4 weeks. We don't have a final exam in this course. We're mainly going to have quizzes and assignments. So your grade will be built upon that. Now you can add your questions here. I occasionally come into the Q&A and I would post reply, or you can send me an email if you need immediate answer. As a student, you can also go in here and answer. So this is more of like a forum environment. So that way we can help each other. If you're not clear on something, you can also post on here and other students can help you as well. But if you want your question to be more private, it's best to send me an email, or you can use inbox in the Canvas course room. Okay, so, and it forward everything to my college email, so I would get it and respond either way. The reason why you see a lot of messages in my inbox is I keep all my messages, so that way in the case administrators ask me if I'm responding to my students, I have records of that. Any question? Okay, no questions? So what I like for you to do is, if you keep clicking next, or if you go to modules, you click modules and go down to the second module, that will be what we're going to be doing today. And so I have submitted a requisition for non-credit department to buy us some equipment. I am hopeful, but I'm pretty sure that we might not get it in time the classes end. So I had asked for them to purchase a few things for this class, so that way you can check them out and then return them when you're done, like how you would check out laptop or other equipment for school. So I will let you know as soon as that becomes available, so that way you can get more hands-on practice, like setting up a small network with a small switch, making cable and be able to attach them. So if this was a course that to be taught in a regular classroom environment, which I intended for it to be when I wrote it, then we would have more of the physical hands-on. But I try to incorporate things so that way you can do it for your home network and or your business network. Okay, so please look at your week 1 notes, and you can view that inside the page itself, or you can download it onto your computer. Make sure that's the right one. Okay, so I'm going to start going over the concept. If you have any questions, please let me know. While we're going through the notes, it's also good to also download the next document, which is your in-class assignment. So you should download this one. And then you can answer while we go through it. And I will stop at some part to go over some of the questions.
I have a question.
Sure.
Is it better to get like the Network Plus instead of the Cisco one, because the Network Plus is more general?
Yes. And while many companies uses Cisco, not all company uses Cisco. A lot of the data center would use Palo Alto, or some different type of routers, switches, and appliances. So if you want to certify for Cisco, definitely that will also be useful. But Network Plus is easier because you only have to take one certification exam. And while Cisco, you usually have to do them in series like Microsoft. So you would have to take the CCNT, which is part 1. And then if you complete part 2, you get CCNA. And then you can complete additional, like the wireless, voice over IP. In order to get to Cisco security, you have to complete multiple before you reach that level. So Network Plus tends to be a little bit more cost efficient, and it's only one exam versus a few. Okay.
Thank you.
You're welcome. I'll share with you some Network Plus information. RCC teaches the CIS824B, I believe, and that's for the Cisco series. It's good, but I think that Network Plus tends to be more demanded in the field. Many employers ask me about students who obtain Network Plus. So if you're looking to do that, it's probably one of a good certification to obtain for this field. Okay, so make sure we download the assignment while we're going through the notes together, and then I'll go over the lab and the project with you before we end the session. And also, if you don't have Microsoft Office, you get a free license as a student, okay? And you can also sign up so that way you have OneDrive. So Office 365 tab is here. You can also find the same information on the website of the college. If you go to RCC, you can find that there as well. But if you click this, it takes you to the Microsoft website. And then it will, you know, on the top right, I believe, there's a download option. It does take a little bit to download. So if you don't have Microsoft Word, Excel, PowerPoint, you can download Office 365. Or if you have an account, Outlook.com, you can also sign into your Office 365 online and then use the online document and save it to OneDrive. Okay, so now to really get through networking in 4 weeks is a little short. I just want to let you know. So I'm going to try to give you as much as I can to really get you to understand the basic foundation of networking and to at least go through, install, maintain on the smaller scale. Normally, networking is taught in a whole 16-week, a whole semester, or in multiple classes because there's so many different aspects of networking. So today we're going to talk about different networks and what is a network. So one of the common questions on CompTIA Network Plus certification would be, what is a network? So in a network, you would have 2 or more connected computers or systems, and they are connected to share resources, whether it's applications or printing or services. In any case, we would have 2 or more systems connected directly with each other or through another type of host or network device. Okay, so in the picture here, this is what you would see legacy, meaning back in the day, where you would have a computer connecting with another computer to print. Okay, now at home, you might have this. Let's say that I have an iPad and I have my laptop and I took pictures on my iPad or download movies on my iPad, and I would connect my iPad to my laptop, whether you're using different type of media like how we would share through, you know, Apple service wirelessly, or we can connect it with a cable in the case where if it's, you know, using some type of cable connecting the iPad to the system, then you establish a network. At home, you have a network, right? You connect to the router routes out your request to a website, and then it sends back, it routes back the information that was sent from that web server for that website. So in any case, you would have communication across 2 or more systems, and all of this data ultimately is saved as 0 and 1s. And when it sends across the network, when it communicates, it's also in digital 0 and 1. So in a network, we would have 2 or more connected systems that can share resources, such as data applications, equipment like printers, copier, external drives, storage, sometimes internet connection. I can use my smartphone, right, to connect to the internet, connect my laptop to the internet, etc. So we can use another system to connect to the internet. So a network is two or more connected computers or systems that share resources such as data, application, machines, connection, and any combination of those. Sometimes you would have all. Sometimes, excuse me, you would have only one element, like I share files. Now, network allows us to streamline a lot of things, right? So you heard about SneakerNet back then. If you haven't, people used to save file on the disk and take that disk, put on their sneakers, and walk it up and down the stairs to transfer it from one computer to another. That's why they call it SneakerNet. Now we have ways to connect the systems. So I can send data from my part of the world, Southern California, to other areas in the world, Europe, Asia, Africa, right? To another country, another location. We now, with COVID-19, can use network to remotely work, right? I can use resources like Zoom to be able to see and talk to you. So network ultimately is what drives the world as far as the internet. And so no matter what happens, we always would see that network is a core in how we communicate. A business needs to have a network so they can process credit card transaction. They can access database of their products. They can have reports from one branch to another, like Walmart, one store to another store. How do they know if there's a product that's available at another store, right? Through accessing the database server, which is connected to the larger network. So in all, I really think that the way we set up our system to communicate relies truly on networking. This is why in technical world, in the IT field, networking jobs is always available. Okay, same with security because we have to protect the network. Okay, so any question? So you should expect something like this on our quiz, okay? And for the second part, it talks about local area network. So when you start looking for jobs, for example, my students, they want to be a network technician, right? Or an IT technician or a network administrator. You often see in the job description, it asks for knowledge or skills in the local area network, meaning that in that physical building, in that business. So a local area network is restricted to a geographic location, such as an office building. Could be a single department in that large building, right? It could be for, and we'll talk about, you know, the variation of this. It could be in your own home that you run a business. So a local area network in general is just a way that we would describe a network that's tied to that one physical location or that's entirely owned by that organization. So usually you would see that that business would own that local area network. all the equipment within: printers, computers, cabling, switches, routers. And then outside of that location, when we start connecting to the internet service provider, which is represented by the cloud on a diagram of our network, the ISP owns their part of the network. So the internet is really a group of different networks connecting together and communicating, okay? Because the website that you visit, you know that it's not physically close to you. It could be in Los Angeles where it's hosted, right, for Google. It could be in New Jersey for Facebook, or Oregon for Facebook, Portland, or in Denmark, right? Facebook has like 16, 17 data center. So, and those data centers service everybody in the world. And how do they communicate? They connect, right, their network through service providers network and then back to their other data center. Okay. So the local area network is really a way that we represent a network to that physical location. And within that, sometimes you would see a work group. And Microsoft, when you set up your Windows 10, right, and you look at your system information at home, you are in a work group environment where there's no security association with one another. So that means that it sees each other as just a different entity. Your computer with the tablet, it sees it as just inequivalent. And we'll talk about peer-to-peer. Now, when you go to work, right, and you log in using a username and password, let's say that you work in an office, you authenticate with your email or your username and your password. You issue that authentication, a client from that your system, which is a client, communicate with the server. So there is some kind of authority in security to issue your access credential. So in that case, it's not a workgroup environment, okay? So keep in mind that the workgroup environment, that the devices have no security association with one another. You can share and control the security of the shared files and the resources, but you cannot really control the other system outside of the sharing sense, okay? Now, but at home, if you use your wireless router to control, right, specific access, then there is some sense of security in that small home network. So sometimes you would see like a blend of like the gray area from a work group blending into a little bit more hierarchy structure. But in most cases, home network is a work group, and it's also peer-to-peer. So to answer the next question, we would have a local area network is restricted to a geographic location like a building, and business would own all the equipment inside that network, right? From the laptop that you use to the computer that the workstation that they have. Now, some business would have bring your own device, right? When you sign up to work for them, they said, here's the contract, but you have to bring your laptop, right, to be able to work here. Now, in that case, you do own your computer, but all the data and all the work that you generate while you're at work, it belongs to them. So in some sense, there's a little bit of the blend in the ownership and that, and we'll come back to this, and I will expand more on it in the next class. However, you're still accessing their media, their network, their services, right? So now the business networks could be computers connecting together, printers connecting together. They would have things like servers. Okay, so we'll talk about different type of servers. In some cases, we would have a mix of the wired network and the wireless network. So we would have mobile devices. Most cases now we do. From the scanner that they scan the product at Target, right, or retail store, all the way to, you know, if you're looking at the UPS person or the person that deliver your package, like from FedEx, the handheld device that they have has to access their network to generate tracking number information and the routing of that package to the right location. So networking is essential, and a lot of the time we operate relying on the network environment. Okay, so you can put down the spanning of a geographic location, and it would consist of systems, servers, etc. for the business. So workgroup, we talk about workgroup as in there's no security association from one system to another. And when we say this, they could be physically on the same segment. So what do we mean by a segment? That section of the network, right? So for example, if you go to Moreno Valley campus, the college campus, if you go to one of the computer lab, right? Or even the library, and you're trying to use computer in the library. So the computer in the library belong to a segment, and that segment is dedicated for those systems. It could just be for library use only. And then you go to another location on the network, on the campus, like a computer lab in humanities building, then that's a different segment of the network. So sometimes that they would design it that way, where each room would have a different segment. Or in other cases, they would have, you know, all the rooms in that building would belong to one segment of the network. Okay. So it really depends on the designer and the person who established that architecture. And that comes back to how we secure those systems as well. How do we protect them in that segment? How do we isolate them from the rest of the network or make them available to the rest of the network?
Question?
Yes.
Is there a reason why we would set up two different network segments at home? Like if we wanted to do some kind of security on one segment or something?
Yes. So if you don't want people to look at your files, if you don't want people to enter your network from another system, then you can put a firewall inside your home network. And I'm not talking about just, you know, using the router firewall feature or using like a software firewall. You can, right? But what you can do is you can also separate them in using addresses, because the way the system communicate is that if it sees it with you know a certain value, it would see that this is the network number, the network segment that it belongs to. So it's kind of like having a different area code or having a different zip code. So you can have the same, you know, you can be on the same street and have different zip code, and the system would see it as in two separate area logically. So yes, I would do that for security reasons. So let's say that you work for a company that they require that you access highly confidential data. So in that sense, that the computer that you use for that work should be isolated from the rest of the network, because now you know that people can circumvent using smart TV, printers, right? People can trick your family members to download something by clicking a link. So you can't really trust internally what's being accessed or used. So then, yeah, you would isolate that particular subnetwork where you would access confidential information in your company remotely. Okay. So, and we'll touch on that when we get into the addresses and to set it up.
I'm sorry, you mentioned something. I don't know if this is going off topic, but I mean, how would you secure your smart TV if it seems like you can access it as a network on the network?
In a simple sense, how can you secure it? Just update firmware regularly at the least level. Or you can separate it from the rest of the network, where you can still have your router routed out, but you can have it where it's a subnetwork, and then on that subnetwork you would have the non or the low secure appliances. Then you would bridge it over to the other, and during that bridge you have to set it up where it would screen. Then also you should also set up like filtering, so that way the traffic coming in and out would, you know, we can port forward it, we can do a lot to it, and then we can screen that port. So there are many ways that you can do this, and companies, they do this all the time, is to, you know, you would have a public Wi-Fi environment where everybody gets on it and who knows what's on it, right? It's still being routed through that company to have internet service. However, all the traffic that's coming from that public network or that public router, or it could be your smart TV, it's being screened when it's coming through. And you can also dedicate routes separately. So you can physically set up a separate router just for that from the rest of your network, and then connect it back to the backbone.
Okay.
So yeah, you're welcome. Yeah, so we can, so just to tie it back to, for people who don't understand that yet, right, is that let's say that we have a smart TV that's super non-secure at home. What you can do is you can have your main right service modem, and then inside it you can have two wireless router that's connected to that modem. Okay, one wireless router has all the secured system on there, your computer, your laptops, your, you know, things that you use that would require security. And then the other access point, or the other router, would have the non-secure, right? When then we connect it back, we bridge them back to the modem that Verizon, AT&T, whoever give you. Then at that modem, what we can also set up is we can screen how the second router is receiving and sending traffic. And physically, when we set it up that way, we logically connect it back, or physically connect it back to one main router. However, right, we can separate the traffic so that way there's no interchange, right, by accident or intentional across the system, and you can do it that way at home. Now, there's a lot of configuration that needs to be done at the main router from your internet service provider, of course. But once you have that set up, right, automates a lot of the security screening, and it separates the traffic for you. Okay. That's one way, but that's more of a general way that a lot of people would use. So that's just to give you an idea of how you can separate your networks into subnetworks. Okay. All right, a workstation. Now the book, the way it talks about this is, you know, it is a powerful system and it's supposed to handle a lot of, you know, use, and you want that in a business environment, right? A lot of the time people refer to workstation as a physical desktop computer, and it doesn't always is true. It's not always true. Okay. A workstation is intended to be utilized extensively in a business environment. So in the lab, like the lab room at a college like Moreno Valley or RCC, you would see that when they purchased the workstation system, they wanted to make sure that it has the hardware resources that's going to last. But now in our current day, a lot of the desktop can be the workstation, right? You can have top of the line i9 computer with a lot of RAM, right? With, you know, physical hardware that would last a long time. So yes, you can have it as a workstation. So there's a mix with that, but I think when people refer to workstation, they sometimes think about just the desktop. Workstation can also mean a laptop, but it's designed for work. Okay, so just keep that in mind. All right. So a workstation are often employed as system that the end user use in a daily basis in a business environment. Okay. Now I want you to look at the Dell, right? Because a lot of companies buy Dell because it's cheap. Well, it's not that cheap. It's more affordable and you can get a good bulk deal with Dell, but you can buy Lenovo, HP, etc. Okay. So here are some of their workstations. So you can have an idea of what that look like. It looks like a regular computer, right? But look at the price and look at the specification. Okay, so if you're buying a more of a high-end system for personal use, you would see it in that range, like a laptop that's at least $1,000. Most businesses don't swap out network systems every year, right? It's supposed to last between 3 to 5 years on regular use. Okay, so in such case, we want to make sure that this has durability. It's going to be able to scale to the need for our application, meaning that I can install a lot of the application on here and it should be able to handle it. So we would have the hardware requirement. Okay. So here what you can do is you can select the one that you would think that would be appropriate for the business. So let's say I go with i9 and I'm just going to soup it up to 32 gigs and up. Okay. And then I'm going to go 500 gig to 1 terabyte. And that's about, you know, the standard nowadays, right? Okay. And then, yeah, we're just going to do a 15-inch. That's okay. We don't have to make it very large because it could be heavier. And then we can add some video cards so that way they can run high graphic based applications. So with that alone, you can see that it's ranging about 3,000 and up, okay, for a laptop. So let's say I have 100 workers in my facility, 100 employees, and I have to equip this for 100 of my employees, so you can do the math there. So that's why we don't want to upgrade every other year, right? And then with this, we also have a warranty with Dell. So in the case where if something goes wrong, we can have them come out and service like motherboard, etc. And then some stuff that's not covered by the warranty, then we will have to service our own. So now if we go solid state, that's going to be even higher. So this is why the other class, the CIS824A, is kind of like the build-up for this, is that you have to understand what would go inside a network, right? Like computer system and the hardware that's involved with that, to really think about how you would design this for longer time use. Okay. So even with the bulk discount, I think we're gonna run roughly between $2,000 to $3,000 for this type of system. Okay. So in that exercise, I want you to visit the website, select the one that you would think would be fitting for your business, arbitrary, or if you have a real business, you can think about that, right? What kind of system would you want to buy for your user? And also, right, want to make sure that it's going to last a while. So just give me a brief description so you can take some information from that website and write it down here. And then if you want, you can include the cost. And then tell me how that system is different than your regular computer, right? One that you would go to Best Buy real quick and spend $300–400 to pick up a laptop. So what makes it different? Okay. I think Dell mainly, they charge extra also for the warranty that's going to back up these type of system, because if you buy it for consumer, right, you would see that when you custom it, it's less. Also, sometimes these laptops is designed to withstand some drops, not all drops, meaning that if they handle it and they drop it on the floor, or it's being moved and mishandled. So in some cases you would see like the rugged type of laptop would withstand, you know, heavy impact. Could be for military use, could be for industrial use. Now on this one, it came with the Windows 10 Pro, right? Higher license than your regular laptop that would have the Windows 10 Home. And then it has a lot of the capability where we can use the hardware to scale for business use. Okay, question. So you do see a sense of you know, that you are buying a little bit more quality, right? And then also the warranty with it. Okay, any question? Now, this is Dell, and Dell owns Alienware, right? So I had established a lab room or computer room at Moreno Valley College using all Alienware. And it's beautiful. So when we come back on campus, hopefully you're able to utilize that classroom. Okay. Any question? Okay, so pick a system. Tell me how that system is different than your regular computer. And you don't have to pick a laptop. You can pick a regular workstation. Any question? All right, so for 5, there are different types of servers. So let's come back to the notes real quick. I just want to make sure I don't miss anything. So here you see a diagram So when you see, right, it labels the switch right here. When you see the arrows on the appliance like that, right, it's just mean that it's passing packets. The difference between a switch and a hub is that a switch can be managed, meaning that we can access its OS, there's operating system in the switches, or its software tool, configure it so that way we can enable a certain connection point, a port, or we can disable a certain connection point. So quickly, real quick, I wanna show you something. So let's say that if I just wanna get a switch like this one, okay? This is a Dell switch, and not just Cisco makes switches, right? You got Netgear, you got so many different companies, but Cisco, their switches utilize their iOS, and there's certain component with Cisco that's different than some of the other ones. So that's why people prefer it that way, but you do have other brands. So this one, when you look at it, so it gives you the model number, right, the series, and then it tells you that it's used for gigabit Ethernet, okay? And then there's additional description about the switch capability. You would see, it will tell you how many ports can be connected. So we can use this switch to be part of, to represent or to connect all the system in that segment, right? Let's say that I have that room, that office room that require 20 computers. I would get a switch that would be at least, right, about 24 ports, because usually they only make like, you know, even number of ports. So 24 ports, okay? Why do I get a 24 ports? Well, what if I hire more employees, right? I need to plug in more computers or workstations, okay? But now when we transition that to the security side, we say, well, if you have all of these extra ports sitting around, somebody can walk by, plug an Ethernet cable in, and there you go, right? They can access your network from the inside. Well, you can control it. You can, if it's a managed switch, you can access its software and disable the ports that you don't use. So even when they plug in the Ethernet cable and try to access your network real quick, they cannot, right? So now an unmanaged switch is just a dummy switch. That's what we call. It's just pass traffic back and forth. It's kind of like a middleman that just pass traffic over here and take the traffic from the other side, pass it over, right? It's unmanageable, meaning that we cannot control. So once you turn on an unmanaged switch, its job is just to pass back and forth. So it's an upgrade from a hub, and a hub is dumb. It doesn't do anything except for repeating that signal and passing that signal through.
Question?
Yes.
Do you have to worry about security on a switch for a home network?
Yes. You worry about security on everything. Yeah, so in a home network environment, let's say that if you have things that are connected, for example, okay, I connect a printer using an Ethernet cable to that switch, okay, and I occasionally print out my homework assignments, and I leave that printer on, right? What will happen is that somebody can access that printer and get to your other part of the network. So in the scale where if appliances are connected to that, because you trust people at home, right? You trust that they, you know, they plug in the things that they would use. However, appliances that sits there that are plugged into that switch could possibly be used in other intention from an external source. Does that make sense?
Yes, I've seen the my printer on the network. So
yeah, so especially if you use Wi-Fi printer, you can turn off your Wi-Fi printer, and we'll talk about wireless and encryption and stuff like that, the type of standards. But yeah, so anything connected and not used, you should disable, okay, or turn off. Best is turn off. But the switch, we have to leave it on because, you know, so usually if an appliance is connected to that port, they can use that appliance to access your other systems. But, you know, in the case where it's wireless, it's much easier, right? Wireless is not that secure, even on encryption level. So, but anyway, it's a risk that we take. So this would be a switch that something like this you would use, and that switch can connect to another switch. That's what we call bridging. Bridging is when we take an appliance and we connect it with another appliance, usually, you know, across the same peer level or sometime higher. We can bridge it to, you know, a router, like a wireless router, physically connect it so that way it transfer our data from inside of the network out and outside in. So this is what we can do to connect all our systems in that segment or that part of the network, okay? Now you would see that there would be, sometime they would use USB, sometime they would use serial cable like Cisco appliances. So that way you can log into that switch, access its operating system or software to configure it, okay? And then you would have, you know, connection to other appliances and or router. So you would see something like this, okay? And this one has 24 ports connecting. When you see RJ45, that's an Ethernet, you know, the plug that you see on an Ethernet cable, that's the plug. It has 2 uplink ports that's at 10 gigabit Ethernet SFP, meaning that that's a different type of cable, and we can use this to connect to our fiber backbone, right, on our rack. It has 1 USB port for data transfer and also for accessing the CLI command line for that device. And then so it tells you, now important when you look at switching technology, look at the capacity, right? How it's able to handle as far as how large of a packet it can send, how is the rate overall, because this is just standardized rated. MAC address table here indicates whenever a system sends and receives in a network environment through a switch, that system is entered into a table as an entry. So think of it like how you go to the post office and you're trying to send a package, right? The post office has a record of your transaction. Very much like that. The switch would have a record of which system sends, so that way when it receives, it uses that table to reference where that system is in the network, what segment that is. It's kind of like how the post office has a table to know that address is on that street, is in that zip code, right? So this is able to handle 16,000 entry. And then here is how we can mount it onto the rack. And there are different rack sizes and design. So that tells you a little bit of information about the switch, okay? In a credit course, after the student takes CIS824B, which is a Network Plus preparation course, they can take a CIS824B, which is switching and routing. It's specifically focused on switching and routing. There's a certification just for that, okay? Because it breaks it up into sub area like voice over IP and some of the other areas. So, you know, everything I'm trying to tell you in the Cliff Note version. So this is basically what you would look at for a switch. Okay. All right. So in the LAN environment, the drawback is that when you connect to a work group, you can access resources from it, which prevents the security. Usually in a workgroup environment, we can share resources, but then there's no control with the authority. Excuse me. And then, so when we draw a network, this is a client server network, okay? So you can have servers, right, on both sides here, right? You have the sales department on the right, and then you have the marketing department on the left. And these departments are somewhat not completely isolated, right? But what we do is we would treat one network and another network as a separate using a router, okay? Now, the modern day, today, currently, our switch, some of the switches like layer 3 and up switch has the capability to route. So in the case where if we want to separate the department within a company, we can assign them different addresses, and with that, we have to use a router to route it, okay? So it's kind of like every time that you assign them a different zip code, it sees it as a different city, and then you have to use a router to route it to another city. So you have to use a router, right, to connect multiple networks together. So this is why at home you have the wireless router or the modem that they give you. That is to route your internal traffic to the outside, right, which is internet service provider, and then they route it out to other service provider, and then eventually to Google or YouTube or whoever that you're using, Zoom, okay? So here they have servers that are controlling the resources. They have a router, right? We can separate them by configuring the router to route specific things. We can also set up switch, right? We can set up sub networks so that way they don't commingle. So there are many ways that we can manage this type of network environment. But in a sense, this is what you would see as a layout of a network, okay? Okay, a workstation, we talked about that already. A server, it's exactly what its name is, to provide service, okay? So a server could do a lot of different things. You can have one physical system that would do multiple things. However, if that system physically goes down, like crash, then multiple things goes down. So I can have one physical server to serve email and web, right? Now, an attacker can target that server physically because he starts scanning and he sees it. Then he can take it down, and there goes my email service and my web services. So my website won't be running and people cannot get their email, okay? So this is why sometimes companies would separate them, but it becomes costly because you have server for file, right? Every time that you access Dropbox, OneDrive, Google Drive, all of these things go into a file server, okay? And then that file server talks to a web server who you are able to access from a web page, okay? Then we have print server. Why do they care about this? Well, there are companies that print lots of things, okay? So that way we can manage print. I can control it where some people cannot print using a print server, or I can limit the number of prints from a certain system, right? Like for example, if that person, that system is only able to print 5 times and that's it for that day, right? So print server allows us to track print, manage our resources, also store in the case where my printer goes down, my technician is servicing it, then, you know, nobody can print yet, but as soon as my printer gets plugged in, my server will have a record, a log of all the prints, and then it's gonna requeue and resend the print. Okay, any question? No question. Okay, so I talk a little bit about web server, and web server's job is to be able to host, right? And so every web page that you visit is being hosted by some web server out there. And you can do that also from home use, but you have to let your internet service provider know that you are receiving, right, a certain type of traffic, and then you can set it up. And with Microsoft, you can use IIS, which is a service that you can set up. Now, you don't have to have a super powerful server system to enable that service. But in the case where we have a lot of people accessing our web page and resources on our web page, we want to make sure that our system would stand. So this is why they implement, you know, more, you know, durable hardware for the server. Okay. And you know, Google don't just have one server, they have thousands of servers that's servicing the web alone. Okay. So this is why cloud business is such a good money making, because you can just buy the hardware, configure it, let it sit there like Amazon, and then other companies would use your space, your hardware, to maintain their business environment. So ultimately, when you use cloud, you're using somebody else's network. That's what it is. You're renting it. Okay. Any question? We don't see fax server that much anymore because we digitize a lot of things now. We have the capability to do that. But state of California require wet sign on certain contract. Okay. So depending on the legislative for certain location. So for example, when you go into a binding contract for property, stuff like that, they require a wet sign, meaning that you have to sign with pen on a paper, scan it, and then submit it, like for home loans, property, stuff like that. And then because we are capable of using digital signature with encryption and certificate to be able to submit who we are to the system. But some state will require that you have wet sign on specific things like will, right? Like setting up a living trust or something like that, where the court also needs to validate your signature. So there's some legal requirement that we might still need to implement the fax server. And application server's job is to manage network applications. And you can do a lot with this to provide applications. So for example, like when you guys are using Web Advisor, that's a web application, okay, to sign up for your courses. Or when you're using an app on your phone to play game, right? It's a web application, but they need to make sure that that's being communicated and to be able to give you what you have with scores and points and, you know, whatever that you have on that game. Telephone server large corporations, this is a must. Okay. And this allows us to control call routing, extension numbers, okay, voicemails, forwarding that voicemail to the user email, like what I have at Moreno Valley College. And all of this come back to the networking side, where we have to set up the switch for voice over IP, connect it to the server so it stores all the voicemail information, and so forth. So when you use call center, when you call about your credit card, your, you know, your complaints about certain products, stuff like that, you're actually using that part of the network that has telephone systems that are interconnected, telephone servers, and the network appliances to handle that. Okay. Proxy server, I call this the traffic police. Okay. And that's since, you know, school days, I always use that. And when proxy server comes to mind, like I always think about the traffic police. So what it does is it handles tasks in place of other machine on the network, or in especially with the internet connection. So so for example, the reason why I say it's a traffic police is, let's say that you drive down the freeway and then there's an accident, and the police, they come and then they reroute you to a detour. Okay, so you have to get off at the exit, go down the street, and then you get back on a different on-ramp. Okay, proxy server does exactly that. Instead of going through the main router, okay, or a main path, what you can do is you can use it to navigate through, or it points you to the direction to navigate through the traffic using alternate route. Why do we care about this? Because if you rely on your main route, you will have a lot of bottleneck, meaning that everybody merges into one lane and there's traffic, right? Like only one car passed through. So what companies will do is they'll set up many different proxy systems to redirect traffic as needed. Okay. So in the case of Google, you know that there are millions and billions of people visiting their site all the time. So if you only have one main highway to google.com, you're going to have a slowdown tremendously. So what we can do is we can separate it, and then we can get the system to redirect, right? Send it to different ways to be able to get there. And so it would be still reach the destination, but it won't have too much of a lag, or what we call latency. Okay. Any question? Okay, so those are the roles of the server. Make sure we know them for possibly quizzes. Okay, so I just need you to identify 3 to 4 types. File, to store and manage file. So if you don't have this at home, and if you download a lot of movies and music and pictures and, you know, videos, stuff like that, you should establish a network attached storage. If you have like an external, like 2 terabyte, 1 terabyte drive, you can set it up. And some of them, you know, you can buy them out of the box as NAS. Okay. Or, you know, so you can have it set up where it's serviced as of file storage, and you can manage it. Okay. And I know that Western Digital and Seagate, they do sell product that have that software tool with it. It's a little bit more than your regular drive, but you can find them. Okay, so pick 3 types of server and put those down. I just put everything there, but you don't have to put all of them. So we'll go up to about 2 o'clock, then we'll take a 10-15 minute break, and then we'll come back, finish the lab, and then talk about the project, okay? Or start the lab. Okay, so in the notes, it talks about hosts. Host could be any system that you can connect to that network, right? Like I can have a tablet that's a host. I can have a laptop that's a host. I can have a server that's a host. I can have a point of sale system. POS stands for point of sale, right? Like where you run your credit card. Okay. So like Square, if you're looking at small business, you can attach that to a tablet, swipe the credit card, or insert the chip. So any host is any network capable device. Okay, so you can attach that to the network. And currently we use Tcpip. It stands for, I added in here so you can see, Transmission Control Protocol and Internet Protocol. Okay. This part of the protocol, I'm going ahead here, but next week we'll talk more about this. Make sure things get where they need to go. Okay. This is, it makes sure, it's kind of like how you get a package and they make you sign for that package. Transmission Control Protocol does that. It doesn't just throw your package in front of your house and then run off. It makes sure that you get and sign for the package and verify that you are who you are. So it needs to go to the right recipient. The Internet Protocol just handles the addresses. So it uses the address to get your, website to you, your email to you, etc. But it makes sure that it needs to get there correctly, accurately, the right way. So Transmission Control Protocol. Okay, so when you look at a job, it might say that. Know how to configure a local area network LAN, right? In a TCP/IP environment. So they just want you to troubleshoot IP addresses and making sure that you set up switches and routing. Okay. Question. Okay. So you saw me doing some of this earlier. I want you to find a router, okay, online. And I want you to find a regular router for this one, not a wireless router, a physical router. So let's look at that. So we're gonna have, let's say, router. Okay. So let's pick Cisco. This is, and when you look at a router, it's pretty obvious that it's a router. You're not gonna have a bunch of ports in the front like the switch, okay? So you are going to get just a few ports because what does it do? Just to connect to a main appliance on a rack, right? Could be a main switch or another router, okay? And then it connects out to the internet service provider, okay? So usually you would see routers now have fiber capability because we use fiber backbone. It's very affordable. Compared to back in the day, we would use other type of cable like coaxial, even copper phone line going way back, right? Like to the late 80s, going to the 90s. So you would see that a router would look simpler than a switch. Doesn't have that many ports in the front. However, you can have more advanced switch that would do both jobs. Okay, you do see some of that. So this one is not bad. It's for the smaller scale. And for Cisco, right? That's very cheap. It's probably refurbished. Yep. So Cisco out of the box is a lot more than that, right? And then people would refurbish these, or sometimes companies would sell them to another company to get them refurbished. And that's how you can recycle your network appliances. Okay, so you can pick something like that. Or if you pick other brand, right, like Firewalla. So this one is a firewall and a router in one. And you do see some of these, okay? Now notice that this one has additional connections, so, and also to the design too. So when you look at a router, you need to take a look at what type of cable you can connect to it, the media, okay? Also the capability on how it would route, okay? So even if it comes with VPN and the capability to control it, it might not be what you need, okay? So this would be good for like maybe smaller scale, medium size. So this is how a rack would look like, okay? I had racks set up for Park Size 16 for that room. Too bad we can't use them right now, but so you also have patch panel. So right here is a patch panel. That's not really a switch. It's a way that we would patch in the cable from other switches. So that way we can reach it. And you want that to color code the cable. So that way, you know, if you have a certain segment, you can have it all blue and then the other one all yellow. So that way, you know how to, it's easier to troubleshoot. It sounds like a lot to really rerun some of the cable, but you know, one of my former students, he was hired just for that, to rerun the cable, and then he had to prove that he could. So, and then right here is the uplink switch. This guy right here, its job is to get all the switches traffic, bring it to the router, and then it forward it to the 4 cable here. Okay. So this kind of give you a little bit of a picture on how they would use this. Any question? And then here's another Cisco one.
Question,
Also,
how do you
yeah.
how do you configure that firewall on the Firewalla? Is that a
It has its own software.
oh, it would,
Yeah,
okay.
you when you out of the box, you should, it usually comes with the DVD or a USB or a link. Nowadays you just scan the QR and then visit their website, and then you put in the product or the UPC or the product number to validate that it is it, or sometimes they'll give you a code and then you can download it. Okay, but even your wireless router at home should have firewall capability built in, which is a firewall is just a screener. It screens what can come in and what can come out. You can block or enable. Okay, so here it tells you the capability of that router, right? Also, all of these appliances have RAM, right? Sometimes they are regular individual modules. Sometimes it uses like DRAM or SDRAM. So, and sometimes those can go bad. I've seen routers where you can swap RAM. Ultimately, it is a system. It's a computing system. So it will have different type of storage. And then Cisco has their own iOS and their own command line system to manage this. Okay. And every model is different. That's what's difficult about Cisco, is that they change the interface and the commands with some of the model. Okay. Question? So in that part of the exercise, I just want you to find a router and a managed switch, an unmanaged switch, which is a dummy switch. It's just switching back and forth. You can't really log into it and control it. AP, access point. Some wireless routers can be AP, but not AP can be wireless router. Okay, because some wireless router comes with access point capability, and then so when you buy access point is a way that we can use it to repeat the wireless signal and control some of it, but it doesn't have the full functionality as a regular router. We'll talk about more wireless down the line. A lot of people think the access point is, but yes, you can have a wireless router that is an access point, but you can have an access point that is not a wireless router. They could be different. Okay. So Fortinet been around for a long time. I remember when they first came out, and this is you would see something like this being mounted inside the facility, right? Like let's say I have a business building and I can have access point mount to the ceiling. So that way my employees and my customer would receive signal, right, in different area of the building. Okay, so you would see something like this, and then some of them are outdoor, so you can mount them outside, like on a pole, or you see them when you drive through Riverside. If you look up at some of the street light, you see some of the industrial access point that's being mounted there. Riverside was one of the first few city in the United States that have wireless network throughout the city. There's other cities as well. Loma Linda is also another one. Okay, so, and now, right, we'll talk about MIMO and some of the other features on it later. But this is the bandwidth, is the 2.4 and the 5G. So find me an access point. Find me a type of server. So you can find Dell or HP. Okay, so sometimes they would look like a tower, sometimes they're not. Okay, preferably I don't like using the tower because we work mostly with racks. Rack mount servers are so much better, save space, because the tower you have to physically sit it, and then but in some cases, some business, they prefer to have a tower, so it will look like a regular computer, so it will look something like this. Okay, but you can have something like this. Poweredge is a beautiful appliance. I love it. So this is a rack mount Poweredge server. This is the series that's been around for a while, but if you look, right, and most of the time servers come with multiple Ethernet connections, of course, or sometimes even with fiber connection. You think that they would have a lot of storage, but the way they sell it is that sometimes you have to add those on. And often we would have multiple core CPU with multiple CPU. So the motherboard is not a typical motherboard that you would see in a regular desktop PC. You would have a motherboard that's able to have multiple CPU installed. So you would be able to have a platform that's computing at a higher level. Okay, so this is why you see the scale and range, and this is just the base. It can go up to 10, 15,000 or even higher, depending on the type of need that you have. Okay, and here you can pick your processor and also the cache. Okay, and then the added processor. So as you can see, and Dell uses Intel, right? So you see different grade of server uses different processor. Most of them use Intel. And then also your RAM, here's RAID capability. You can add RAID, which is where we can use multiple disks for storage. We can add solid state, and we mainly deal with terabytes and up, right? For most part, because you want it to have heavy duty. Now for small businesses, you can go with a little bit less in storage. So let's say that I can do a hot plug for hot swap 14 terabyte alone with just storage. That adds another $1,400 on top of my machine. So already we're at above 5,000. Okay, so just to kind of give you an idea of how expensive and, you know, the type of hardware that goes into a server. Now, if you don't like Dell product, you can also see HP. And they have different ones. I think I bought the ProLiant, yeah, for MVC for Parkside 16. So here's the ProLiant, if it will load, that is. Yeah, I'm getting a little bit of bug in that. Let's look at the tower. Maybe we'll have better luck.
How much RAM should a server have?
It depends on what you use for, but yes, at least 32. It can go up a lot more. You can go, so it depends on the OS that you're using as well, right? So if you have 64-bit, it's scalable with a lot of RAM. You can go up to terabytes of RAM for all that matters. But if you're using 32-bit OS, like old server, like server 2013 with 32-bit, yeah, you're very limited to the RAM because it's not going to handle very much RAM at all. So, all right, so here's the ProLiant, and as you can see off the box, you're gonna have some storage with the Gen 10. Okay. And this one is also using the Xeon. So that's the series of processor that you often see for server use is the Xeon. Okay. Xeon can be slow too. Don't be surprised if you look at a Xeon and they will be slow. There's just like i9 or i7, there's different grade of it. So sometimes even if you see that series, it doesn't mean that it will be super fast. But yes, they are usually multi-core.
Question, what is slow for a server? What do you mean by?
I've seen them from even at 2 gigs level. So even currently, you see some processor at 2 gigs and up. So, you know, for me, I think for a server, if you're looking at 2-point-something gigs, that's very slow, even with multi-core. So if you should go at least like close to 4 and up. So, you know, because you would have different processor handling this. So yes, like for use, if you're processing a lot of data, then a lot of requests, then we would want a good server that would be decent fast. Otherwise we'll have bottleneck, right? Congestion. We don't want that. So you might have multiple servers just for that. So as you can see, right, different RAM sizes, drive bays, power supply, that's essential. 800 watts and up, sometime 1,000 or more. So it all depends. And it runs hot. So that's why server room needs to be very cool. Okay, go back to the network. Do you have any question for me? So we'll go about 10 more minutes or so, and then we will take care of our lab after the break. So in the next question, I touched on this briefly. It says, what type of network device is used to connect to the wide area network? And that's, you would use a router. The router is often referred to as a gateway. And that is and back in the day, you can use a server as a gateway, but it's a big no-no now because for security reasons, you don't want to service people and make it like a gate to your network as well. There are different type of firewall that's enable router, right? So you will see some border firewall that is also a router as well. On the smaller network, if you need to route from, let's say, one branch to another, sometime that they would use an L3 or level 4 switch, which has the capability. So anytime, next week we're going to talk about OSI layers and you're going to see it more. So anytime that is higher than layer 3 in the OSI is when it can route. That means we can assign it an address and it can sense it to that address. So, and then, so if we want to buy a smart switch, they call it sometimes a smart switch or a layer 4, layer 5, layer 3 and up switch, you can use it for routing as well. But traditionally, the router, its job is to route traffic in and out, and it can be called a gateway. Okay. In your home now, you have all systems at the same level where nobody is higher than anyone. Sometimes you can share resources like files, picture, movies. All the appliances, all the computer and the tablet and such, they see each other as equivalent, and that's what you would see as a peer-to-peer network. Okay. So when you access like BitTorrent or some of the peer-to-peer server, right? What it is it's servicing you, it's searching for a certain type of data or files that you're looking for, and then it will tell you there's a peer, right, somewhere in the world and on that computer, you know, it has a file like the music, the song that you're looking for, or the movie that you're trying to download. So it's pointing to that peer so that way you can access their shared folder and download it. And that's all it's doing, is really a peer-to-peer, you know, file sharing environment. Okay. Now at home, you can establish that too. You can set up a share to your PC, right? And then you'll be able to access it using a Mac system to that PC, or a Linux system, or another Windows system. So definitely easy to do. So in a home network, you often see a peer-to-peer. Okay. Now, if you think about, if you go to like, you know, public Wi-Fi places like Starbucks or something like that, their stuff is still controlled by you know, their main network. In hotel, you have to authenticate now and then issue the given passcode to be able to access. They control it a little bit more for security reasons. It won't have the best security, but it, you know, at least they can track who's in their network and who's not. So if you go to an internet cafe, right, that they don't really manage it, where, you know, if you buy a coffee and then they give you access code and you can be on it for a while, right? Or sometimes you can pay for some of the internet service if you travel overseas at internet cafe, like you pay for the hour used, it will cost a few dollars. Then in such sense, you would likely be in a very similar network to your home, where they put up a wireless router and everybody gets on it and nobody really gets control over it. So it becomes very unsecure. Okay. I travel with my hotspot every single time. I don't ever use public Wi-Fi. Like at the airport, that's the worst. So I've watched many live seminars and demo from people, security people, right? Professional hacker, that they showed how easy it is to even look at images that people were looking at, websites, stuff like that. So there are tools for those things. Okay. All right, any question? Okay, one more and then we'll take a break. So when you're working with the network, there are two sides to the network. Number one is the physical topology, which is the physical layout of your network, the arrangement of your network. Number two, logical network topologies is how the data is moved across the network, how it's passed across the network. And that has to do with configuration, addresses, right? And to really establish the movement of data, of traffic. So the main difference between physical and logical is that the physical pertain to the physical connection, the arrangement of that system segment, right? Separate room and different area. We can be in the same room and access different network, okay? That would be established using logical topology. So the logical topology is a way that we can logically separate them on how the data is moving, okay? Even though they can be in the same physical room, okay? So a lot of the times you see the parallel that the physical and the logical would be to parallel to represent departments, right, for their functionality, or, you know, different sub-networks within that organization, okay? They can have the same or different in topologies. And, you know, one of the position in the network environment is the network engineer, and the network engineer mainly looks at how the network design has been established or to be established and be able to design that for security reasons, for operations reasons, and such, okay? So if you don't become a network administrator, one of the other position that you can get into that pays well is a network engineer. And network engineer makes good money, okay? Usually those network engineer transition over to security architect or security engineer because they already understand the functionality of that network, so they know exactly where to protect that network and what to do with that network, okay? So you cannot get through security without understanding the entire aspect of networking. It's really, you know, that's the foundation to security. Okay. Question? Okay, so what I'm gonna do after is we will move a little faster. However, we will finish. I'm gonna take a break. I'm gonna give you a 15-minute break so you can, you know, rest a little bit before we start back up. So be back at 2:15, and then we will finish and talk about what we need to do for the lab and the project. Okay, any question before we take off? Okay, so let's take a quick break, 15 minutes. Be back at 2:15. Any question before we start back up?
Yes.
Yes.
I used a router as a Wi-Fi extender because
Okay.
my Amazon Echo wasn't getting the signal.
Mhm.
So I put a 20 character password on the router being used as a Wi-Fi extender. Do I need to do anything else in terms of security?
No, because that would just allow you to protect that extender for as a repeater, right? Because you're repeating the signal, the wireless signal for a
Yes.
different part of the house. I would recommend on the main router or the modem that you have from the service provider to configure it so that way you can filter. So I would do a MAC address whitelisting. I'll walk you through that in the next few weeks on a similar router. Okay. So
Okay.
you should add all the devices on your network using MAC addresses. And then anything that's not in the list, it won't allow connection.
Talking about for the Wi-Fi extender or repeater or for the main router?
The main router. Because the repeater, when you password protect it, all that is just to protect the configuration at that repeater. So it's still gonna need to be added to the MAC address list for the main router.
Okay.
So in case where if they break your encryption in the main router to be and try to connect, they can't connect another system. So when we whitelist, we only allow certain system to be connected.
Okay.
Now, if they enter through a connected system already, then, you know, then we have to have an additional layer of protection.
Yeah, I got Norton Security, so I figured that would take care of that part.
Yeah, and you can set up firewall filter on the main router as well. But I'll show you how to do that in the next couple of weeks.
Okay, thanks.
Okay, so we'll start back up. Any other questions? So during break, I looked real quick on the type of jobs that you might be interested in. And since if you're new to the field, you want entry level. This one is the data center technician. And it requires a little bit more than, you know, what we just talked about in this class. However, you can expand your skills by taking additional courses or buying books and learn and or look at resources online. So here's some of the responsibility. That's what you would see. And then there's some Cisco 2 layer 2 that's for switching. And then so a lot of it is just servicing different type of OSs, troubleshooting hardware, troubleshooting some network capability, working with web server and database, and so forth. So this is in Ontario. You can check this out. It didn't say how much it pays per hour. So you can probably look at the website that's advertising for that job. We do have an apprenticeship program for IT and cybersecurity. So if you sign up, I will add that to this course announcement. So you can sign up and Jennifer will work with you on that. Okay. But there are different type of junior level of technician work in networking. So if you're looking usually, if you have very little or no experience, you want to look at the junior level of networking jobs. Okay, lots. See? Okay. So Here it talks about wide area network after it goes into host, so wide area network. So anytime we refer to the wide area network, it's beyond our local area network after the router, right? When it goes into other networks. So when often you would see it drawn as a cloud, meaning that it will be alternate networks that's outside of yours after it leaves the router, okay? For example, like if you're visiting Google website, Google have their network and their network connect to other networks, internet service provider and other types of network, which connects to your network. And that's how we have the internet. So the WAN usually use router ports to route, and we'll touch more on the router down the line, but the router, it passes from one to another really quick. Okay, I'm going to show you something real quick in Windows. So here's my command line. Let me change the font so you can see. And it's something that you can learn to do. And I'm using Windows 10. Let's do 20. 20 plus 20. Oh, still very small because I think I'm zoom in. Okay, let's go big. All right. So we know that we can look at IP addresses, and at home, if you have Windows, you would do IP config, right? Now, on Linux system and on Apple systems, you would do IF config, okay, for IP address configuration. So this gives me my general addresses, okay? We'll touch back on this. So here it tells me what domain I'm connected to. Usually that will be to your service provider, and then the addresses for my system. One thing that you can do that's fun is, is to do Traceroute and a website. Now, not all websites will allow you to do this because they would block it for security reasons, but in general, you would find some websites that allow you to do that. So who actually blocks it? Facebook does that. Who owns Instagram, some social network website, but we can find other ways to find their information. However, they would use a security company to shield all of that. So let's say that I'm trying to trace the route from my computer to Google to see where it goes, okay? And this might take a little bit also depending on traffic. Okay, so it's leaving my computer, right? And here it uses version 6 addresses. So it passes, as you can see, through many networks in order to get to Google. And often that you would find these are public IP to other routers, and other routers pass them to, you know, other router inside or that's connected to the network. And then here is Google web server information that hosted google.com. Okay. And that's the address for it. Okay. So what you're seeing is that it could be more than 30 hops, meaning that 30 network that we crossed. Okay. However, your operating system command line, like Windows 10, only can track so many, right? Because it's designed to only show so many. So think of it like how you go from your home to school, right? How many streets you cross, how many highway do you cross over? It's very much like that. How many city, how many town do we go over in order to get to destination? So from our home, where we visit Google website, you would see that it passes through many networks until it gets to the web server that hosts google.com. And every website in the world is hosted by some system, right? So that way it would have the HTML file, so it would serve for the HTTP when you type that in to your URL. And so you can see, and it would track differently. Sometime the beginning, of course, is the same because it's the same service provider. And then as you leave, you would get to different networks and then eventually Google or your destination. Okay, so this is a command called Traceroute, and to just do trace RT and then a URL or an address. You can use IP version 4, IP version 6 address if you know it. Okay, and it uses public IP. So we have two different IP. Inside your house, that's what we call internal or private IP, which is for that network only. And every network can have different IPs inside. But on the outside, it would have a different IP address. Meaning that, think of it like this, like somebody would have a legal name and then they would have a nickname at home. So inside the house, everybody knows that person by nickname. But then when they leave the house, when they go to school or when they go to work, they would have to use their legal name. So the public IP is what is known to the world as us, our system. And then the private IP is internal use for that system. It's different. Okay, so that's kind of previewing what we see next week. Now going back to this, you kind of have an idea of how data is routed from one end to the next. It would go to a larger geographic area. And so without local area network, we won't have the larger WAN because WAN is built on many lands, right? Thousands and millions of lands from here to the entire world. Okay, so now we would have an internetworking of lands and we use a router to internetwork that. Okay, and the router routes based on IP addresses. Okay, and the transmission protocol, its job is to use that address to deliver different types of data to different systems. Okay, so in the next part, after number 10, it's gonna go into topology. Let me come to that part first. Okay, so here you see some diagram. Oh, also I want to mention before I forget that the internet is a distributed WAN. Okay, that's different. It's interconnected in different places and it consists of different type of systems. So it's kind of spread out, distributed. So when we say distributed, it's distributing it out to different local area network. And the WAN sometimes is referred to as centralized, meaning that it's composed of a central, some form of systems or connected system and devices. So ultimately you should have that in the LAN and then the LAN connected to another LAN and so forth. So we touch on peer-to-peer already. Client server, we touch on that, right? It would have authority over, the server has authority over the other systems for application, for file, for email, for connection, for user account access. Okay. For the previous question, you can refer to page 5, which talks about topology, physical and logical. Now the bus technology is old. The topology that's used back in the day was the bus. And they use the phone line to do this. So you can tap the line to connect many systems. So it would use the modem to dial up to connect to networks, right? The internet. And on the bus, you would have a main line that's running through. And then on that line, you would tap it for the type of system that you want to connect. And we use a dial-up modem, right? Modem is just a way that we would convert analog signal, which is phone line, to digital signal, okay? And that was more in the 90s, right? And then when we approached 2000, we digitized a lot of the technology that's capable of digitizing the signal. So now completely everything that we use, right, in North America is digital signal. Now, other part of the world is a little different. There are some parts that's still using dial-up, but very little. Question? Okay, sorry about that. Probably accidentally got unmuted. Okay, so the bus technology was not very efficient, right? The benefits of that is that it's easy to install and it wasn't expensive because we only have one main line and then we tap that line, okay? So therefore, the drawback in that is that when you troubleshoot, it's really hard to determine which system is down. If you change and move, that could be difficult because you already tap it for a specific area in that line. You don't have a fault tolerance, meaning that you don't have a way to have a backup in case something goes down. So when that whole line is down or that one system is down because it's passing from one to the next, nobody receives data, okay? So bus is still being implemented in some network when we bridge system, right? Remember earlier I talked about bridging? So when you connecting, let's say you have many branches and then you connect it back to the main network appliance, one of the switch is connecting to that router using that one line, okay? So the target would be, from an attacker standpoint in a network environment, if you have, let's say, a firewall and then a router and then a switch connecting, they would try to get through the firewall, and if they want to cripple your network, they would attack that router or that switch out to the rest of your network, and you're done, okay? So this is why we don't rely on a single point failure, meaning that that one appliance that's doing everything for the rest of the network. We would have fault tolerance, meaning that we would distribute it out to multiple appliances to handle the traffic, okay? So think about it. If you do everything in your home, and if you are incapable of doing the tasks, the chores, the things in your home, what happens? Everything stops, right? Like if you're the mom that takes care of the kids, cooking, cleaning, everything, and if let's say that you're sick, you can't do it, then everything stops. So we don't want to have a single point failure. We want to have fault tolerance, meaning that we want to have redundancy, multiple system that's going to handle that, pick up the chore, pick up the task in case one goes down. So the bus issue is that it's incapable of having fault tolerant, in that if the beginning of the bus, that first system, if it gets shut down, right, it can't pass the data to the next system and the next system and the next system. So it's a very straight through linear, you know, and in that if we establish that, that's also called point-to-point topology. So to answer that question, the benefits of the bus is it's very easy to install. We only install one line and we tap the line. It's very low cost, cheap. But the drawback is that you don't have administration or control because people see your data across the network. There's a lack of security because it's very visible to everybody else, the data. There's a single point failure where one system goes down, it takes out the rest, and then fault tolerance is lacking. No redundancy, no backup. So now it really depends on the purpose of that different areas of the network. And in some cases, business would make a decision based on cost, right? Like I can bridge a system, one cable, done, right? Physically, if somebody enter my server room, cut that cable, I'm toast, right? Nothing gets routed, nothing gets bridged, okay? So physical and logical security is tied back to physical and logical configuration of networks. Okay. Then we came up with a star topology. And the star topology, think of it like how it spoke out from one central point and then it spreads out, right? So it's like a hub. So if you have a switch and then you connect everything to that switch. So at home right now, right, you're using a star pretty much because everything connects back to that wireless router, okay? All your devices, okay, that connects back to your access point or your Wi-Fi, your wireless modem, okay? Now it becomes a single point failure, right? Because if that wireless modem goes down, like in my home right now, right? If that gets shut off, I get no internet. Okay. So we do have issues with using one central point. Now, in that case, if you have a system that distributes out data to 5 other systems, right? From a security standpoint, we say that we just attack that system, find the target, take down that target, and then the rest won't receive data. Okay. So what you want in a network design is always think about fault tolerance. If this goes down, what can I do? Okay. So the benefits and the disadvantage of the star topology is that you can add new station and move it quickly. It's easy. Just add another line to it. Okay, so you can scale out your network. Let's say you hire more people, you can add workstations to that switch or that hub. Okay, and the hub is dumb. It cannot be managed. It's like a repeater. It repeats the signal. The switch, it can be managed, right? And we can configure that. A single cable failure won't take down the entire network. So if we cut a cable, that would just disable one of the system, but the rest of the network is still functioning. So it's more advantageous compared to a bus topology. Okay, how we arrange it and connect it. So those are the benefits. Now the disadvantage for star is that the cost can be more than if we compare that to a bus, because we have more cables that comes with price. And like I said, there's a single point failure. So if a central device, that hub or that switch is down, or your wireless router is down, nothing gets connected. Okay. Now in Michelle's case, she mentioned earlier that she has the repeater. It'll still repeat back to the router, but your main wireless router is the point where it passed that to your internet service provider. So we still relying on that centralized system to handle the interconnection with the rest of the world, right? Okay. Any question with this? Make sure we know the differences between star and bus for the quiz. Okay. So that's what a star looks like. So the benefits and the advantages and the disadvantages is on the bottom of page 6 and going to page 7 of your notes. Then they came up with the ring, which is a loop bus. So it's exactly what its name is, right? So you would, instead of connecting it linearly, you take the last system and you reconnect it with the first system. Now, this textbook and also in this notes, I didn't mention that there's a bi-directional ring and then there's a single directional ring. So sometimes you have a ring inside a ring, right? Like where it would go one way and then the other way. So when you have two rings that's incorporated, meaning that you just use two sets of cable for each computer, then you do have some fault tolerance and redundancy. However, the cost of the installation is much more. Okay, so the ring itself is pricey. It's hard to configure. Also, you have to have an adapter that has multiple Ethernet connection, or back then they would use, modem. So you have to have two modems and you have to configure the modem. Now, some ring is still being used for Sonnet network, okay, in WAN. And Sonnet is for testing purposes. And so you do have the physical ring implemented in some part of the world still, but it's not that common. Okay, so when we have a break in the ring, if it's a single direction, a lot of the times we are also losing connection to the rest. Like if I have a break of a cable right here, okay, then that will cause disruption. So ring is not that great. And then you have mesh technology, and mesh topology came about where people want redundancy and having fault tolerant with connection. So that means that from a system, I would connect it using 3 cables to 3 other systems. Okay, but think about if you have thousands of systems, that's a lot of cable. That's a lot of connection. So the cost is high. Doesn't seem like it's the best option. Okay. Often you would see some backup systems would use hybrid in a network, hybrid mesh in a network environment, where you would have multiple connection to that backup systems where it backs up all the data, and then it would connect out to another system to back up its backup. So you do have some hybrid mesh, which is a combination of a bus with the mesh and with less connection, like a full mesh. Okay, so let's look at the next question. So I want you to use this website. This is a tool that you would use to draw a diagram. And there are so many different ones online, okay? And when you work on your lab this week, you're gonna do something similar to this. So within this, what you can do is you can start from scratch. So it says that start from scratch or from the template. And then what you can do is you can pick a template that's here, okay? Now let me see. Let me reload that. It should give you all the template though. I don't know why it didn't. There it is. Sorry. I don't know why it didn't load for mine the first time. So from here, you see that there are shared resources on this already. Now, if you sign up for the account for this, it only gives you like some free things and then, you know, you have to pay. I don't want you to pay. You can just select one. So here's the star network template. So if you go down to the bottom row and then you would select the star network template. So I want you to get used to looking at network diagram. Okay, so notice that it spoke out to the other hub. So I have a main hub and that main hub connects to two hubs. Those two hubs connected to the computers in the segment, two separate segments. And then that main hub connects to a third hub and that hub connects to the computers in its segment. Okay, so once you go on the website and select star topology diagram, I want you to take a screen capture of it. And how you can do a screen capture is go back to the website here. If you press Alt and print screen, or print screen by itself will do okay. But Alt and print screen let you take a picture of the active window. So once you do that, press the Alt and the print screen. The print screen button is on the top right of your keyboard, and the Alt is next to your space bar or near it, okay? Now, if you're using Mac, I put in a link for you to look at the screenshot instructions because Apple uses, you know, different keys. So once I press those buttons, it saves it into the memory of my computer, right? Into the clip, the clipped file. So what I'm gonna do is I'm gonna paste it and it will look like that. Okay, so you can right click and choose paste and you should see the screen capture. Okay, so what that does for us is I want to introduce you to a network diagram tool which you will be using for the lab, and also to take a look at different templates like the star topology to see what it looks like. Okay, and this tool you can drag and drop, right? It's really easy to do. Just like all the other tools. Now, Microsoft released its own software called Microsoft Vizio, which is used for diagramming networks and creating Gantt chart and other things. It does cost. I try to get the IT people to get some licenses for the campus. We'll see how that's gonna go. So you can use online tool like this. OpenOffice has free packages called the VRT network packages. So you can install OpenOffice and then the package as well. Question? Okay. And as you can see, if you want to modify this, you can add more to it, right? Like if I wanted to add like a telephone, I can put that in here. And then I can use some of the tools here to connect it. Okay. And the lab walks you through that.
I have question, Professor.
Sure.
The main hub and the other hub, they are same specs.
Yes. So in this case, everybody's our peers. They're equal in role. But what happened is that they connect 3 of the hubs back to it, right? So this hub eventually would connect to other network appliance to have internet service. So it would connect to like a router or another switch. But yeah, they would usually be equivalent. Now, in some cases, they might buy different appliances, but the role is the same. It's just passing signal. So this hub pass signal from all this system to this hub. And it's going to take those signal and pass it out. Or pass from here to here, right? I can be at this workstation and I can communicate with somebody that's sitting here. And it uses this hub to pass it through this way, and then this hub pass it to the next hub. Okay. Or I can be sitting here and I want to communicate with someone here. So I can go, it's going to pass it up this way and then up this way, down here to this hub, and then to the destination. Okay, so that allows us to have inter-network within. Question? Good question. So once you have your screen capture and see, right, you know that ring and mesh is rare in general because of cost, and we have better ways to have our topology design, but that's legacy wise. You do see some of it, but it's rare. So ring and mesh are rare in today's world. Okay. So now if we go back to this right here, okay, this star topology, this can also represent point to point, okay? So remember I said that I can be sitting here at this workstation, let's say number 1, and I need to transfer my data to number 6 over here, okay? So I need to go from a workstation to the hub, from the hub to another hub, and this hub to the 3rd hub, and then to that workstation. So literally you're going from point to point to point to point, right? I can't just go from here, boom, to that workstation, of course. So what this established for us is that we would pass it from one system, and the system pass it to the next system and the next system. So that consider to be a point to point. So an example of the point to point topology is router to router, hub to hub. You can put that, computer to computer, a switch to a router. Okay. So if we want to do point to point to point to point, then we would have a router to a router to a router, right? So ultimately, if we're looking at the LAN, you saw how I did the Traceroute earlier. It's router to router, right? So when it leaves your network, it's going to take your packet and pass it to the next router, which is in another network, and then pass it to the next router, and so forth. Okay. So in the really the structure of WAN itself is really a point to point or a point to multi-point. In some cases, we can set it up to where it would go from one point and it's going to go boom, spread it out, you know, to all the other router and then come back. But usually you see it as a point to point in WAN. But in your network, you can have it different. Okay. So those are some of the example of a point-to-point topology, a router to a router, a computer to a computer. So when you transfer your data from your phone to your computer next time, think that it is it's a point to point, right? A point to point. Okay. An example of a point to multiple points. So let's say that I have data in my database server, right? Or let's say I have a data in a system and I wanted to send it to everybody in the network and we can broadcast it. Okay, like think about the radio. They broadcast it from one location, right? But everybody that turns on that channel receives it. So you can have it from a point to multiple points. Or I can send it to only 2 computers, right? And I can establish that from that hub or that switch, and then only to specific system that's connected to those ports. Okay, so we can have a router to communicate with all the other routers in our network or across the networks. We can have a switch that sends it to all 5 computers that are connected. Okay, so that would consider a point to multiple point. And you see that happening, especially in the case of, you know, when we connect all the appliances and all the system together, the system sometimes it asks the other system, hey, are you available? If you are, here it is, right? And sometimes says who's available, and then 4 or 5 of them will be say me, and then it's going to pass it to those, and then those pass on to others, and then so it becomes a point to multiple point, and then to possibly point to point or multiple point again. And that's how we get data from one point to the next from a very simple concept. Okay. Okay, so I hope to handle this by 3 so I can walk you through the lab and the project. Okay, so when you design a network layout or trying to upgrade or implement things to your network, this is some of the things you need to consider. From a business perspective, first thing they're going to ask is cost. How much is it going to make? How much more are we going to spend on this, right? The second thing that you have to think about when you design a network is how easy it is to install, right? You can take an existing network, which is what a lot of the engineers are hired to do now, is they have to work with an existing network and scale it out or make it workable, operational with what the goal is going to be for that company. So how easy it is going to be for the installation, because, you know, cable means cost, and then sometimes you have to cut through a wall or, you know, drill things through to drop cable and add connection media. Okay. Now, sometimes simple solution doesn't always mean the best solution, and low cost solution doesn't always mean the best. So you have to weigh in a lot of different things. Think about how easy it is to maintain, right? Is it simple as replacing that cable? Because if that cable goes bad, do you want to crawl into the ceiling to pull that cable, right? How, when you install it, you think about how the maintenance would be after that. Also, fault tolerance requirement, meaning that is it going to be, if something goes down, will it be impacted? Especially when we deal with servers or critical systems. So if you're looking at airport or airlines company, right, they have to have a lot of fault tolerance, because if people cannot buy tickets, or if their system goes down, they cannot track planes, flights, seats, and they cannot sell tickets. Okay, so it impacts scheduling, it impacts a lot of different things. And they are a network, right? Every time you go to the airport and do a check-in at your luggage, you know that that terminal is connected to the larger network, right? To their database to track and make sure that you do the check-in. And then it also notify the airport security system that you are there. Okay. And then the other element that we sometimes forget is that security requirement, physical and logical security. Server needs to be in server room locked, right? Network appliances, major ones like the router, needs to be on a rack in a locked environment where people cannot access it. And then also security in the configuration. Okay. Any question with this? This is somebody's job. Okay. As a network architect engineer, that's your whole goal. Is cost, installation maintenance, fault tolerance, goals, and security. And then some security architect, this is these two areas. That's all they do. Okay. Question. Okay. As you go further in the notes, you would see CAN, which is campus area network. And they're not talking about just college campus or university, but that would mimic it well, right? Like you go from one building to the next building, they would use either satellite connection or fiber connection. So it would encompass several buildings. So the next time you go down to downtown Riverside or City Hall area in any city, right? You got the courtroom, right? You got some of the offices that tie back to that city. They might have one tall building where all their employees work, and then they have the legislative areas, and then they have, you know, so all of those are tied to a network, and that network is called CAN, Campus Area Network. Your home is considered a PAN, Personal Area Network. Okay. And then it's also can be a LAN. So a LAN can be also be PAN. So inside the CAN, you can have sub-networks, right? Like each building would have its own segment. So that way they can share case file information with the courtroom and so forth. And then the city would have like a system to manage and track resource services like, you know, power or water, etc. And that ties back to their network. So utility management and network administration is a very challenging area for industrial. It's not easy, but there's always, you know, needed in such areas. So you do see some jobs and work in that. And then for 19, the storage area networks is where it would have a collection of your data, and this is the system that we would use it to manage data. We can use file server and a lot of drives, right, to be able to establish a storage area networks where people can put their data on there and be able to access it from anywhere in the network. And you do see this on like the cloud, you know, drive that you access. But it has a web interface where it also connect to the web front. So there's a web server, and then that web server would forward it, right? After it authenticates you. So there's some, it also ties to a database server where it would have the username and the password information, or authentication server. And then once you authenticate, then it brings you to the file server structure, which is a storage area network. Sometimes you see it as SAN. We call this as SAN, right? Sometime, and it's different than NAS, which is network attached storage. Okay, so many acronyms, right? So you master IT when you start remembering it just like this. So you get to a point like me, after a few years, I'm like, oh, it's this, it's that. So after a while, if you use it so much, you remember. So SAN stands for Storage Area Network. Okay. So I want you to find a SAN online that you can use for home. They're not cheap, but I want you to see what it is. So for 20, search the internet, find SAN. Very easy. You can simply put this into your search engine for home, SAN for home. When I look at this yesterday, it gave me cheaper system. Okay, so you see a range of them. Some of them are in the thousands of dollars. Some of them are in the hundreds, right? So they have a range and you can specify or filter your search. So let's say that I wanted to do this one. So this is a link station with 2 terabyte personal cloud storage with hard drive includes. So this allows you to do what? Put all your pictures and data and everything here so everybody on the network can access it if you allow them to. Okay. Like let's say that you have a lot of family videos and pictures and you want to share it with your family members, you can do that. Now let's say that I want to go a little bit higher. Okay. Let's say I own a home business. You can, this one is actually easier to set up. It's about $1,000 and then you have these drives right here. So we can go 16 terabyte, 24 terabyte, 8 terabyte, and 16 terabyte runs about 1,000. You know, yeah, this is my cloud. So basically you have your storage set up. See how it says NAS server, network attached storage server. So its job is just to store data. Okay. This one has like a little interface with the screen, but you would use a computer that would connect to it to configure it, and it would have some of the tools that would come with it. You can also use server operating system to manage this, but it's a computer itself, right? You have some memory, you have processor, and you have storage. So basically you doing a point-to-point. You're connecting your system to that to configure it. And then that system, from the point of that system, it's going to connect to multiple points, all the tablets, all the computers that's connecting to this to be able to access the file. So you have that within. Okay. Any question? So I want you to pick one. There's no limit to our choice there, right? You pick one that's, you know, high or low in price range with the capability, but I want you to check out the SAN. Okay, question? Let me check the chat for a second while you're looking at that. Okay. If you miss something, we'll have a little bit of time at the end. I can show you if you miss a question or something like that. And no question with the assignment. I'm going to move to the lab now. Okay. So after our assignments, if you complete it today, you can submit it, but it's not due until next Saturday. So it gives you time to look it over if you need to. Okay, so let's have some fun drawing network topology. I think a lot of my networking students, this is their favorite area, is besides configuring, of course, but you can download the document here, or you can look at the instructions in here. So at the end, I want screen capture of your drawing, right? We might not be able to address it right now, all of this, because, you know, you still have to make adjustment, but I want to preview it so you can do it, right, outside of class if you need to. So the document instruction is there. I want a document that contains screen capture. So, or if you do save it as separate file, you gotta make sure you upload all the image file for me so I can see it. Okay. So let me open up lab 1. And this is fun to do. You can design your own network. So we're going to use 2 different tools. Part A, we are going to create a home network, and you can mimic it like how you have at home, right? So before you draw it, maybe look at, you know, what your router is connected to physically or logically, like go into it and look at it, or you can just come up with your own, okay? So I'm gonna just do one real quick, and then, so your topology should have a wireless router, some computer systems, right? You can use laptop or workstation or desktop there, and then mobile systems, so maybe smartphone, tablets, and then if you want, you can throw in some smart devices, okay? Like TV, and you know, there are a lot of things that we use. I have a refrigerator that's smart, but I'm not connecting it to Wi-Fi. So we have a lot of different appliances now that we can do that, okay? All right, so let's go to this website real quick. And you don't have to sign up for it. If you do sign up, they give you like 5 free documents, and then they're gonna try to charge. So I don't want you to pay, okay? So once you're on the website for part A of lab 1, you just simply click start drawing now. The tools nowadays are so nice compared to before. Okay, so let's talk about this real quick. So here is your canvas to draw, right? Everything on the left are different types of shapes and objects. You can also search for it if you want. We don't really need a lot of this. Now you can share this when you finish, right, if you like, but you have to sign up, log in, and to share. So first we are going to give it a title, right? I just want to make sure that you do that for professional use. So click the T for text on the left here, and then simply drag it, right, onto the right. Now you can expand it by pulling the corner, just like how you adjust pictures. And then after that, you can type in something. You can have home network topology, or do it as it says in the lab. So here, it tells you to do CIS824B. So let me do that. But when you do this professionally, right, use the tool that your company would approve, of course, because, right, they want to make sure that sometimes you don't want your network topology to be floating around and be shared on people's cloud. Okay. So let me retype this. Okay. So this is our lab 1 home network, and then we want to put our name. Now here, it already give you in the template. So here is your wireless router, so you don't have to add it. Now, if everything is connected wirelessly, that's great. We can just throw stuff on the canvas by dragging it, or if you have it connected wired, right, using a cable, then you have to draw lines, okay? So let's say that I add, I'm gonna add a notebook. So just drag it on here, and you can size it from the corner like this. Okay, just hold down your mouse button and then drag it left or right to size it. And then if you want to label it, right, we would always want to label either, you know, putting IP addresses or computer name. So let's just, you know, arbitrarily give it a name. Laptop 1, right? Or you can, you know, if it belongs to your kid, you can put your kid's name there or initial, whatever. So we put laptop 1 because the reason why is that we're going to start throwing a lot of stuff on there and then you're going to get lost which is which. Okay. Now, on this one, we wanted to have, I'm going to add the signal, right, to represent its Wi-Fi. Okay, and you already seen that as Wi-Fi here. Or if you wanted to add additional, sometime we can use the link com with the lightning strike to show that it's connecting. Okay, so let's put some smart devices on here. We can drag it and then we can type it. iPad 1, right? Now, most company, they would decide system name in a theme or a scheme, right? Mainly for identification purposes. So in case if the system goes down, you know exactly, you would use your network diagram to know where that is geographically and what segment that belongs to. That's the whole point in diagramming out your network. Okay, then I can throw on an iPhone and then we can say iPhone 1 or whatever number. And I think this one, it has computer, so PC. So, okay, so let's put it over here. Now, let's say that your PC is connected to the router using a cable. You would use the tool called connector that's located here or up here. That just shows line. So I'm going to use the tool called connector and I'm going to start with the PC. Just, I didn't have to click anything. Just move your mouse and then attach it. Oops. Come on. There you go. You got to go to that little small bubble. Otherwise, it's not going to attach it to the right area. Okay. Now, if you want, you can add colors to it. Sometimes that helps. With the more advanced network diagrams, sometimes we use color to represent different segment of and how we wire it. So, you know, but at this stage, we don't have to. So we can just say that this is PC 1. I didn't want that to label there, but so let's say we want to add text here. Oh, come on. And then we can move it. So we can say PC 1. Okay. So you can have fun with this. And then when you're done, just take a screenshot for me. Say, paste it onto a document or save it as a file so you can upload it. Now there's different types of phone for this one. So this is a phone. They have a conference phone. So whichever one you like to put, that's okay. But for home, we probably use a regular phone or this type of phone, right? Like a regular phone here. Okay. Now the cloud just represents internet, right? It goes beyond, it goes into internet service provider and other part of the network. Okay, so you get an idea of how to do this. So if I want to add wireless signal on this one, I just drag it and then make it smaller. Okay. So now you have a point-to-point, right? A point-to-point. And this one, it can broadcast out to all of them. So it could be one to multiple point. They're all peers, so they're peer-to-peer. And then we can add a printer. We can attach this printer to our PC like this. Okay. And then you can label it too. Printer one. Or sometime we would put the brand like Canon printer and a number. So some company would use department to name, or, you know, I don't recommend using location like in the building because that's a security thing. And they would use like acronyms to represent the department so they can identify that system belongs to that segment of the network. Okay, so have fun with that. That's part A. And then for part B, you're gonna use the other one. You saw this in the assignment already. It doesn't look as nice, but it's another tool. Okay. Now this one, you have to start out with the template, or if you start from scratch, it's a little bit more work. Okay. So when you do make a network diagram, it's gonna present all the template. Then you're gonna choose the template that's stated. So in the part B of the lab, it tells you to choose make a network diagram. I'm sorry, you click that and you're going to choose network switch diagram. That's the template you're going to use. So it gives you the basic and then you can add more to it. Okay. So I want you to add one router. So you're going to connect that router to the switch. And then you can bridge the switches, or you can have two switches connect to the router because you need to have the router to route out. So all the switches need to connect back to the router somehow. Okay. And then, and it walks you through on how to connect it. I type it out for you. So one switch, you're going to connect all the workstations, the phone and the printers. Switch 2, you're going to connect the copier, the wireless hub, so you can connect mobile devices to it. So near the wireless hub, you should have some mobile devices along that line. Okay. So I'm going to do a brief one real quick to show you. So here's the network switch diagram, which is like in the second row, this one. Okay. So it takes like a second or two to load it. So here it is. You already have one switch and you already have a PC connecting to that switch. So all you need to do is you need to add another switch and connect that switch to the router. So let's say if you're not sure, put your cursor onto the device. Okay. The load balancer here, its job is to make sure that it distribute and control the traffic balance that's you know, leaving, going into the network and such. So they look kind of similar. So you can put, here's the switch. The switch is under the lock. Okay. So if you click it, it shows it on here. You can drag it anywhere. Okay. So I can put it here. And then you can make it smaller so you can put more onto the canvas itself, like this. Okay. So I have already a PC connecting to that switch, and you can label it if you like. So I can put another PC and then I move it. So just click it and then it will show up. Okay. So what we can use is we can use waypoints to connect it. Going from here. Actually, I don't want that arrow. Oh, there it is. And you can change the elbow of it by just dragging it up and down. Okay, or the angle, I should say, like that. Okay, so make sure that we look at the instructions, and it's going to tell you on number 7, part B, how you would connect one switch. And then ultimately, those switches need to connect to the router, and then you'll be done. Okay, and we would use line to represent cable. Okay, switches are not wireless in business environment. They use cable. Okay, you can add in label and text to make your network diagram look nice. Okay, so they already have some label for you here, but if you, and then we can, okay, and then you can use this line to connect your switch. Okay, any question? Now, the tools is as good as its library of objects. So sometimes you might not have everything that you need. So you would use some form of text to really indicate what you mean. Because, you know, the router, the way we can tell the difference between the router is the 4 arrow versus the switch. It's angle, it's like an X arrow. So that's how we can tell the difference. But all of that looks very similar when it's super small. Okay. And then your wireless hub is on the bottom here, so you can scroll down more to choose your object. Okay. Question. No question, huh? So I would, for
No
the
question.
4-hour course, it takes me like at least an hour to get YouTube, convert everything over. Zoom does take a little bit to give me the video afterwards. So I usually come back to my computer 30 minutes later, it will be ready, maybe sometime an hour. So I would try to get it up tonight, but I can't guarantee it. Okay.
Question
Yes.
for the home network. How do you make the cable connections?
On the other tool,
Yeah,
that one. Yeah,
no,
so you can,
on the
yeah,
app
you,
creately.com. Yes.
okay, so on this one, if you click on the device, it should show you the draw connector option.
Okay.
Yeah, or you can also use the line button. But if you click on the actual device, it gives you the options with those. Like draw the connector, and then you can, you know. But when you draw, it's gonna look for, see how it shows the little X in gray? That's the connector point. It won't connect until you click on that, on those little connecting points. Okay.
And for the wireless?
For the wireless, you just use the wireless signal like this.
Okay, thank you.
Yeah, and just drop it. Click it and drop it. Okay. I don't know when we're going to rerun this set of courses again. The dean did mention that she might allow it to run in spring. And I might teach it, I might not. It all depends on how my schedule would be for spring. We have to finalize the schedule in the next week. So I'll have a better picture of the schedule and if it's going to be offered. Also, my department is being split, so we will no longer with the business department after this semester, after the fall, going into the winter. So with that, I would have to, you know, we would gotta make sure that our schedule is gonna fit for the changes. So there's some changes based on the guided pathway. So I'll keep you guys posted on when the first class is gonna be available again, or when this course or the next course is gonna be available again. I think a lot of the students are asking me that because they missed this round, they want to take the next one. But now, in the summer, we plan to run the IoT one, which is Raspberry Pi Arduino, and designing IoT, which uses Google Coral. It's really cool to prototype. I wrote those courses as well, so we will have those available so that way high school student can also take it during the summer. Okay, so play with this, do the lab, give me the 2-screen capture for your network design. But in the second one, I want you to do part B is a business network. So, you know, follow the instruction there, okay? And then when you're done, just submit those screen captures on a document, or if you have them on individual file, it's okay. Okay, so play with that. It's gonna be fun. Okay. What do I want to tell you? Oh, let's talk about the project. Okay, so in the project for this week, and it's not due until next week, I want you to look at your home network. So let me open up my document so it's easier. So project part 1 basically tells you to take your smartphone or your web camera and you're going to take a picture. And I don't need like the whole entire thing. You can have like a laptop connecting to it or a desktop. And if you don't have a home network, what you can do is you can use somebody else's home network. That's fine. Okay, so but the whole point is to look at the devices in that network and then to be able to see how you can maintain it and upgrade it eventually if you need to. So first, take a picture of your network, okay? And then what I want you to do is put down the type of devices that are wired or wireless. So if I have a desktop PC that's wirely connecting to it, then I would put that down. I would put down a wireless laptop that's connecting to my router. So put down as much information as you can. Then you can use our notes to identify the type of topology that represents your home network. Is it point to point? Is it point to multiple point? Is it a star? Is it a bus? Is it a mesh? Is it a hybrid mesh? Etc. Okay. Then what I want you to do is I want you to be on your computer in your network. And if you're using someone else's network, you can also run a test. Okay. So within that, you have to write down your result. Now, it's different running a test from a wireless system like a laptop compared to if you connect a cable, that would be a little bit more accurate on the wired, because on the wireless, you're going to be a little slower. okay? So this is, I looked at several websites. There are other websites, right? But I tried to pick one that doesn't have crazy advertisement all over the place and you wouldn't know what to click. So here, it usually would tell you who your provider is right off the bat because they have only a number of registered ISP for internet service in a certain region. So when you just simply start the speed, and it doesn't take very long, right? And when you do this, you would see it different during the day, at night, and in various time depending on the network. So last night when I did this, definitely faster compared to now. I'm on Zoom, and also, you know, even though I pay for the service, the line is still going to be shared with a lot of the people in the area. So and it would be more accurate also running it from using an Ethernet connection with a wired cable. Okay, so keep that in mind. So once you have the information, write down the report. The reason why is that in the next couple of weeks, we're going to talk about speed and different type of media and how they're connecting. Okay, any question? Okay. So in the project, what I want you to do is do a speed test for me. Once you have that detail, write it down or type it in. And then on the bottom, it tells you right here, right? Like, what is that compared to the rest of the people that's using that service provider, right? That part of the region. So it tells me that in general, I'm faster than 16% of some of the other home network, right? So that you can add it to the bottom where it says added additional information of the result. Okay. Any question? So the IP here is the public IP. So that's why it looks different than your internal IP that you see on your computer when you do IP config or IF config, right? And then the ping here, we'll do some ping down the line. And then here's my upload speed and my download speed. Now, if you have exactly the same, right? In some cases, people, if they're using DSL, when certain type of DSL, you're gonna get the same speed. But in most cases, what you see is your speed varied, of course, and your upload speed and your download speed are never the same. Okay, in most cases. Okay. So I'm actually uploading faster than downloading right now. Question. Okay. So that's pretty much it on my end. So check your speed and we'll interpret more next week to see what happens. Okay, so I'll give you time for the rest of the session. You can work on your lab and your project. You can turn that in by next Saturday. And then don't forget that we have a quiz 1, 10 questions, multiple choice, and it's self-graded. Okay? All right, so I'll take questions if you want to stick around, but before you go, please type in your name in the chat, your full name, so that way I can get you for attendance in case. And put your name in the chat, please. And work on your lab, your project, your quiz, and I will see you next week, okay?
All right, thanks, Professor. I'll see you next week.
Okay, you're welcome. Take care. Bye. You're welcome. You know.
Thank you, Professor. See you next week.
Thank you. Bye. Also, if you guys need internet at Moreno Valley College, they put up their public Wi-Fi. So if you go to the campus, you're able to connect just like how you did before with all your devices. So if you need internet and because you don't get that locally, you can go to the campus and they have internet service now for students to use. So you can use that in the meantime. There's some packages, so that's free for 3 months. Any questions? Make sure we add our full name in the chat before you go. Thank you. Okay, bye, Debbie. Jessica, you have any questions? Well, I hope you feel better, Jessica. I'll see you next week, okay? Let me know if you have questions. You can send me an email.